So as Dan mentioned, my name is Michael Johnson. I am a BI consultant out of Johannesburg, South Africa. Today I'm going to be speaking about real-time analytics with Azure Streaming Analytics. So yeah, let's just dive straight in. So what would I like you to learn today? The big thing is I'd like you to introduce you to the idea of streaming data. We'd like to have a look at how Microsoft has created the Azure Streaming Analytics sort of service that you can consume, and then we're going to finish off with a demonstration, basically creating a simple end-to-end streaming solution. This talk is aimed at a sort of 200 level, so nothing should really be too challenging. So what is streaming analytics? Well, so I, like most database consultants, I've always thought of data as being data. We get it, we store it, then we query it. Well, it turns out that there are other ways of thinking about data, and more specifically is how do we deal with data that's actually still moving. We haven't had this opportunity to persist it to some sort of store so that we can query it, and that's where streaming data comes in. So let's have a look at sort of data as we know it, and then before moving across to sort of data, this real-time streaming data. So a very common scenario to describe sort of batch data or data that's been sort of persisted is batch data. So batch data is data that's been received, it's been written to some sort of storage medium in the SQL Server professionals. That is often a database, but it could be a file system, really could be many sort of storage media. But it's come to rest, and that's why we can query it. The alternative to that is obviously streaming data, which could be thought of as moving traffic. Now, the problem with moving data is that we can't bring everything to a halt. We can't create this bottleneck to be able to perform these sort of queries on it. So we need a different set of principles that allow us to perform computations over this moving data. So a simple example, sticking with our car theme, is a toll booth attendant or parking booth attendant. Now, let's say our parking booth attendants, part of their duties is to, every hour is to log how many cars there are in the parking lot. Now, in a traditional batch-based world, what would happen is the parking attendant would have to lock the booms so that no cars could come in or out. They would then run around the parking lot counting all the cars. They would get back to their little booth, jot down how many cars there were, and then open up the boom so that we can get new cars. Now, as database professionals, we sort of understand this idea of locking the booms. These are your transaction isolation levels. Because we can't have new data arriving, halfway through the count. Otherwise, we'll get these distorted values. So this transaction isolation is pretty important, but it causes all sorts of problems. In our booth world, in our booth example, customers wouldn't be happy if they had to park outside waiting for the attendant to come back. So a different solution to this, and this is really the way we deal with stream analytics, is that our booth attendant would simply implement a counter. The counter, every time a car arrives, increment by 1. Every time a car leaves, you decrement by 1, and then you have this real-time value for how many cars are in the parking lot. So this is a different way of thinking about data, but as we'll see a bit later, is pretty powerful. So where is all the streaming data coming from? Well, the internet is a big source of it. We have what we call clickstream data. So this often comes from things like weblogs or maybe your shopping carts from your e-commerce sites. But we also have this new sources of data, such as social media. Think about Twitter, Facebook. All of these new streams of data that come in at just amazing volumes. Then we got IoT. So IoT is obviously the Internet of Things, and that's all these loosely, these small little devices that are able to transmit certain bits of information about themselves. Probably one of the biggest implementations of that is telematics vehicle tracking, where these cars will submit their GPS locations, speeds, perhaps various other sort of facts about the car. But it's not just cars that have IoT devices attached to them. We also have IoT devices attached to ourselves. You know, we've all got these little sports watches nowadays that keep track of the number of steps we've taken, our heartbeat, our perhaps our temperatures. And then there's a sort of growing trend of all these sort of IoT connected devices. You see a little picture of a IoT-based fridge, but you get IoT-based TVs, even little pet care products, so that you know exactly when Fido has gone for a walk. But you got this whole range of streaming data. So let's have a look at Microsoft's solution to dealing with all of this, which is Azure Stream Analytics. So what is Azure Streaming Analytics? Well, simply put, it's a real-time event processing engine. And what this means is that it has the ability to create these queries over moving data. And because this data is moving, it becomes key that we understand that when we ask questions of this data, we don't ask a question like how many cars are there in the parking lot. It's actually how many cars have gone through during this window. So this idea of a time window is pretty important, and we'll see how that's implemented in a sec. So why would Microsoft want you to use Azure Stream Analytics? Well, they've got sort of 4 key areas that they'd like. At first, it's easy to use. Now, I don't know if anybody here has tried to set up an Apache Storm cluster, but it's generally beyond the skill set of most of us. I know I've sort of tried to do it once or twice. It was a very frustrating experience. The Azure Stream Analytics solution is also incredibly scalable. Like all of Microsoft solutions, there is a handy little scroll bar that you can basically just shift to the right when you want more power, shift to the left when you want less. And that's how you can scale up and down. Basic increments are you're going to run from somewhere from about a megabyte per second all the way through to a gigabit per second. Then it's reliable. Microsoft have spent a lot of time creating this sort of highly available solution. That meets a lot of your SLAs. I believe it's 5 nines. So that sort of infrastructure is pretty hard to create on your own. But you've got the support of Microsoft behind you, and finally low cost. We'll see that. So from the cheapest solution, we actually run from about it's $24 a month, which is pittance if you think about some of the costs of setting up systems like this. So let's have a quick look at how Microsoft implements some of this. Okay, so we're going to have a look at the high-level architecture. This isn't a sort of deep dive. It's a level sort of 200 type talk. So we're going to speak about, we have our inputs, we have the streaming analytics sort of process itself, and then we have outputs. So what kind of inputs do we have? Currently, Azure Stream Analytics supports 3 types of inputs. There is the Azure Event Hub, which is basically a messaging queue where all of these little IoT sort of messages can get queued. Microsoft has also created the Azure IoT Hub, which is essentially an adaptation over the Azure Event Hub, specifically for the IoT use case. And finally, there's Azure Blob Storage. Now, blob storage isn't really meant as a streaming mechanism, but is a handy method for bringing in reference data. We'll speak about that a little bit later. For the outputs, there's a far richer array, and probably some of the ones that we're more familiar with. Being database professionals, we obviously like to see Azure SQL databases there, but it also has NoSQL solutions like Azure Document DB, Azure Lakes, Azure Table Storage. There's also options like the Azure Service Bus. So if your streaming analytics solution is outputting events that need to be actioned, the Service Bus might be a good option for you to push those messages out where another workflow process can pick it up. We can also output to another Azure Event Hub, so we can actually perhaps pass that on to another streaming process. And finally, we can use Power BI for sort of real-time analytics. Now we're going to conclude this talk with a demonstration where we'll actually be using the Azure SQL database and the Power BI sort of outputs. Now, at the heart of Azure Streaming Analytics exists this idea of querying. Now, for anybody who might have had a look at Apache Storm, it uses a language called Scala, which is its default language, but you can also use Java, there's PySpark. But these are languages that as database professionals, we're not familiar with. We're not used to that sort of procedural languages. We like our set-based languages. And Microsoft have thought about this, and they've actually based the entire stream analytics sort of language on T-SQL. So you're going to feel very familiar. Let's have a look at what that might look like. So this is a very simple query. I'm sure even though you might never have used Azure Stream Analytics, most of you guys could look at this and actually understand exactly what this does. So what it's doing is it's taking an input, it's grouping by the make and this tumbling window, which I'll get to in a second, and it basically it has an having clause where the count is greater than 3. So what that's doing is, well, go and fetch me all makes of cars where we have more than 3 of them passing through this window. So the bit that's different is the tumbling window. So the tumbling window is this notion of temporal data. So this is how do we group data as we process it. We have 3 windowing functions, which we'll discuss in detail now, but basically that's how we're going to group it. So let's have a look at the rest of the language process. As you can see, there's a lot of functions that we're all very familiar with. Selects from, where's, group by. There's a lot of the date functions, a lot of aggregation functions. You'll see some of the scaling functions, but as I mentioned, it's the windowing functions that are really going to be different, that are going to bring something new to what you do here. So let's go have a quick look at how these windowing functions happen. So the first one is the tumbling window. The tumbling window essentially creates a petition at a set increment. So in our example, we have a tumbling window. We're using seconds, although the time increments could be, I believe it's hours, minutes, seconds, milliseconds, and nanoseconds. You would then obviously specify the window size. In our case, it's 4. So you can see basically we have the first window happens from 1 to 4. The next window happens from 5 to 8, and the last window happens from 9 to 12. So this allows us to group all our events into these 4-minute seconds, and that's great for sort of determining perhaps peak flow. So at what time increment did we have the most cars passing through our toll booth? The next one is the hopping window. So the hopping window is very similar to the tumbling window, except it has an additional parameter called the hop size. So we begin by specifying the window size, but at the end of the window size, then the next window, instead of the next window starting when the last window ended, the second window will actually start after the hop size has been reached. So our simple example, we have a window size of 4, the hop size of 2. So you'll see that the first window starts at 1 and then runs through to 4. The second sort of window runs from 3 and then runs through to 6, and that will continue incrementing by 2 every site, but always maintaining that 4-second duration. Now this is going to be great for windowing functions or sort of moving average functions when you kind of want to understand how perhaps sort of normalizing that trend a little bit. The final windowing type is one that's a little bit harder to understand. So you see that we have our first window. So we've specified the sliding window. We've given it a duration of seconds and a duration of 4. So our first window begins running from 1 through to 4. This window will then increment by 1. It'll continue to increment by 1 until until one of 2 events happen. Either an event that was in the window fell off, or it picked up a new window. So you'll see here at this point we've gained an additional event. So we have our first window, then our second window would actually have occurred just after, so basically running from 3 till 6. But because this window is empty, as in there are no events in it, it is discarded. So the next window that is valid would be would be this window over here, which begins when we pick up this event that happened in number 7. We get a new event happening at 8 seconds in, which creates a brand new window. That window would be valid until the sliding window reached 11, in which case, the event number 7 would have fallen off. That creates the next event, and then the final window happens when we reach event 12. Now it is fairly complex to explain. So if you guys have questions about that afterwards, I do understand. It is pretty tricky to explain. Okay, so what other enhancements are there? Well, one of the things that they've introduced is this idea of supporting JavaScript UDFs. So this allows us to write functions in JavaScript and actually implement and actually consume them within our query environment. Now, there's a couple of limitations to this. The first is that these functions be stateless. So this means that you can't use things like variables to try and pass values from one function call to the next. The function must also be compute only, so we can't make external calls to other functions to perhaps go to disk, or perform any others, perhaps user inputs or anything like that. And the final one is that there's no external connectivity. So this means that you're not going to be able to make API calls to enrich data in any way. So, now, why would this be useful? Well, if you think about all the JavaScript or some of the JavaScript libraries that are available to us, the big ones that might be useful are things like regex, which allows us to do a lot of string manipulation. That's something in SQL we still struggle with. So that's really handy, as well as other libraries, perhaps like the math library, which give us access to a large array of powerful functions. The next powerful feature is the Geospatial Queries. This is a new feature. It went live about a month or 2 ago. Essentially, what this allows you to do is create these geospatial types and then create geospatial functions over them. So the data types that are supported are points, lines, and polygons. A point obviously being a one-dimensional point. A line is obviously just between 2 points, and then a polygon is obviously a completely connected shape. So polygons are going to be great for denoting area. Lines are obviously great for determining something like perhaps like a distance, and a point could be the position of your car. So here we have a very simple query that we've implemented. If you see in the yellow, we have a table called cars, we have a table called stations, and we've joined the two, and we've asked the question: give us a list of all cars and stations that are within 10,000 meters of one another. So that's 10 kilometers. So now, if we use this as an event-based system, we could inform drivers that they are within 10 kilometers of a fueling point. Now, combined with something like the fuel tank storage, we could use this to determine if this is the best time to refuel. Another exciting addition is the Azure machine learning. Now, this allows you to actually enrich your queries with your machine learning experiments. These make calls and then returns them before outputting to the output. So this really gives you the ability to extend your model quite a bit. Now, before we go to our demonstration, just quickly have a look at some of the development and deployment options. So the first, I'm sure everybody's familiar with, is the Azure portal. So the Azure portal is a graphic process for creating all your objects. Now, it's really handy for demoing things and learning. But as you're going to see in the demonstration, where we're going to use the portal, it can be a little bit clunky. There's a lot of copying and pasting. So a better solution when you're looking at if you're actually going to implement this is to actually use the SDKs that are available. So within Visual Studio, you can actually go and create your own Azure Stream Analytics projects. You can create the inputs, outputs, as well as the transformations. But some of the really useful functionality is the ability to source local input. So you don't need these events to be in the cloud. You can actually go and create the sample JSON files on your own on local machine before pulling them in, and then you can sort of obviously run them and evaluate the process. You also have the option to deploy directly to the cloud, which is really handy, as well as you can point to your own cloud instance where you can actually generate a project from an existing application. So you can backport that if you need to. And the final option is obviously PowerShell. PowerShell is obviously great on the administration side. I don't lend myself naturally to PowerShell, so I wouldn't use it as my development platform of choice, but certainly some of you might. Okay, and then before we get to the actual demonstration, I just want to speak about streaming units. So streaming units are how Microsoft provisions sort of capacity. It uses this idea of a streaming unit, which is limited to 1 megabit per second. Now, at first, 1 megabit per second really doesn't sound like a lot. If you think my hard drive can do 400 or 500 times that. But if you think that at 1 megabit per second over the whole day is actually 84 gigs, which is actually a lot. That's a lot of data to be coming from, sort of to be collecting. And you're not limited to, obviously, a single streaming unit. Now, by default, you can scale up to, I believe it's 30 streaming units. That's on the sort of default Azure portal experience. But if you need more, you can speak to Microsoft, and they'll provision up to a gigabit per second, which that's a lot. So around about pricing, pricing is dealt with in two components. The first is the volume of data. The price for data volumes in Azure is around about 0.1 cents per gigabyte, which is pretty cheap. And then the streaming unit runs for about 12 cents per hour. So if we were to run a single streaming unit for a month, we could ingest up to 2.4 terabytes of data. The data would cost us $2.50, and the streaming units $86, which for $88, that's a lot of compute power. All right, so I'm going to switch now into my demo, just so you understand where we're going to, what we're going to be doing in this demo. The first thing we're going to be doing is we're going to be creating an event hub. We're then going to create an event generator. So this is just an application that's going to simulate events getting generated. We're then going to connect that the event hub to Stream Analytics. Then we're going to do two things in Stream Analytics. The first we're going to do is we're going to persist these events to a database. So what we're going to do is I've already spun up a database, and we're going to basically write all the events as they come into this database. The second thing we're going to do is we're going to use Power BI as an output, where we're going to monitor our stream of data in real time. Okay. Let me just get. Okay, so bring up the portal. So just close it. Okay, so the first thing that we're going to want to do after opening the portal is we're going to go and create a new event hub, which we can obviously do by going. See if I remember. So that's. It's actually probably right there. That's the easiest version. So the first thing we're going to do is we're going to go and create an event hub sort of service. I'm going to call it Business Analytics. Now, this is obviously required to be a unique name within the service because we're actually going to create a HTTP endpoint on this where events can come in. Going to select the standard pricing tier, just so have a look at this. We have a basic and the standard tier. The basic tier is obviously more for your development, not probably something that you'd want to use in a production environment. You would probably want to stick to the standard pricing structure. Going to use an existing resource group, and I'm going to use the Western European Data Center. Now this is part of where I said earlier that the portal experience can be a little bit slow. There's going to be little periods of waiting for certain processes to finish. In the meantime, I'm going to go and create a new streaming analytics job. So exactly like the event hub, we need to create the job name. unlike the Event Hub, it's not going to be public accessible, so there is no requirement for a completely a unique name. I'll use the same name. Add it to my. I'll then create that. Okay. Seems our Event Hub has been created. So the Event Hub service obviously spins up, creates or creates a service where our events, but we're going to create the Event Hub, which is where our data actually arrives. So I'm going to simply go and create one there quickly. I'm going to call it Hub just to keep things simple. We have a few options with this. So we can set the petition count. Petition count becomes particularly important when we're looking at scaling. Our solution is obviously very low scale, so we're going to leave it at 2. I believe it goes all the way to 32. Okay, and then we have the message retention, which is the number of days. So remember, this is a streaming solution, so the data is never persisted, but it still needs to remain within the system. So we can set it to maintain or receive messages for 1 day all the way through to 7 days is the max. Again, I'm going to leave it at 1. I'm going to create the Event Hub. Let's wait for that job to complete. All right. While that completes, I'm just going to we'll begin with the second phase of the project. So now that we have an Event Hub, we need to gain we need to be able to allow access to our application that we're going to go and create. So we're going to access the shared access policies. We're going to review the root manager, and anybody who wants to access my system, and now's the time for you to copy this down. I'm going to quickly go and grab that. Okay. So this is the connection string that our application is going to use. This obviously uses the service bus. So let's have a look at what that application looks like quickly. So I've already created an application for you. We have 2 options that we need to fill in. The first is the connection string. The second is the name of the hub that we called hub. Okay, so this tells our application where it's going to send these messages to. Let's have a look at the application quickly. I've created a very simple application. It's going to track temperature. I've set this temperature to begin at 40 degrees. I've then created a max and a min, so I don't want my temperature to sort of go beyond 50, and I don't want it to go below 30. And then what I do is I randomly generate a number, and what I do with that number is I then, if that number is if the number is greater than 50, then I want to increment the temperature by 0.5 degrees. If it is below 50, I wanted to decrease the temperature by 50, and then if it's exactly 50, I want it to spike at 60 degrees. And this is to simulate an event, a sort of a negative event. If you think about your IoT scenarios, this is probably something you're going to want to do. This is your perhaps a wash plant overheating, perhaps your servers, whatever it is that you work with. Then we're going to create a simple JSON packet. Now I'm not inherently a developer, so I've chosen to use a little bit of string magic to generate my JSON packet, but you would obviously use probably one of the JSON libraries to implement a proper solution. So once we have the message, we've got the Event Hub client that we sort of created over here, and we're going to submit we're going to push that message onto the queue. We're then going to write the temperature at the screen, and then we're going to wait for sort of 0.2 seconds before we begin the loop again. And this is an infinite loop. So our Event Hub has been set up, so it is ready to collect strings. So I'm actually going to kick off this little application, and if the demo gods are on my side, should have a little console application appearing shortly. me a second. All right, okay, so there we have it. We have this random data. It's sort of going to trend towards the middle, but it is going to vary. So that, hopefully mimics some sort of real life sort of data scenario. Okay, so let's go back to our portal. We know that we've created our event hub, and we know that we've created our Stream Analytics job. So we're going to go and connect to the Stream Analytics job. Just going to go and grab that connection string over there. So I have another screen open on the side with copying and pasting all the little magic bits. Going to come back to our window, and here you can see we explained the very simple architecture on how it works, and here you can see that implemented. We have inputs, we have queries, or query in this case, and we have outputs. So the first thing we're going to do is obviously going to go and create our input. So we're going to go and add. Keep naming standard, we're going to call it input. You can see the event type is either a data stream or reference data. So reference data is great when you're looking to enrich your data. Perhaps if you were using vehicle telemetry, chances are the identifier coming in would be something like a VIN number. So you might want to enrich that data with perhaps a driver or vehicle types. So that kind of additional information. And then the data stream is any data coming in from either your IoT or your event hub. So we're obviously going to have a data stream. We're going to choose the event hub. We could also use the blob or the IoT. And then we've got this little option over here, which is great because it's we can use event hubs within the current subscription. It's never ever worked for me. I don't know why. So we're going to have to go and use we're going to provide our details manually. So we're going to go and just going back to that connection string that we had earlier. So we created our event hub name. Called our hub was just called hub. Event policy. It was called route managed shared access, and then we had that key right at the end. Sorry, just the key for quick. All right, and the final option is this consumer group. Now, if you don't provide a value, it uses a default value, which you can see over there is just $default, which is exactly what we're going to use. You then have two sort of formatting options. You can either use a JSON format or a CSV. Hey, there's something new. I didn't see that. Maybe that came out in build today. I'll have to go and dig into that. It's an awkward moment when when they show something new. Okay, so we're going to use the JSON format, and we're happy with UTF-8 encoding. So we're going to go and create that event. Okay, so we can basically go into this detail, and this gives us the values that we had. We can obviously go and test it, so we can go and test to see whether the output is valid, which is hopefully the case. Just give it a second. Okay, so our event hub works. We know that we can connect our input, and then we're going to go and run a sample. We're going to go and sample the data. Now, when we began out, we said that streaming data isn't persisted anywhere, but during the development phase, you actually need some sort of sample data to work with. So you're actually required to go and generate this data sample before you actually begin development. So we're going to quickly do that. We're going to select our sample data. This is essentially going to go and monitor the system for 3 minutes. It doesn't take 3 minutes. It'll come back fairly quickly. Now you need to remember that this is actually going to your stream in real time. So if you aren't submitting events to your stream, it's not going to come back with anything. We obviously have we already have a system that's generating these events. So you can see we came back successfully. Quickly go back and view our data. You can see we have the option to download it. I quickly go and download it. It puts it in my downloads, just to show you what that looks like. And I don't have Notepad++ on this machine. It's okay. So now, if you remember in our .NET application, we created a JSON string with a temperature in it. But if you actually look at this package, you're seeing a lot more. So the first thing you're seeing is the event processed time. So now we can see when the event has actually been received. You can also see the petition that it got sent to. We had we used 2 petitions, so you'll see the petition count could either be 0 or there should be an instance of where it's 1 somewhere. Right over there. Okay, so we know which petition it went to. That may or may not be useful to you, depending on your query requirements. And then there's also this event enqueued time. So this gives you the time when the message was added to the event. Now, if you wanted to know if your streaming unit was sufficient to deal with your workload, a good indication that it isn't is that there was a growing difference between the time it was enqueued and the time it was processed. This just indicates a bit of a bottleneck. All right, so now that we have a query, we're going to go and modify our stream meliscus query. I should probably pin this because it'll make it a lot easier to find. Okay. Sorry, no, I didn't want that one. Although if anybody might have noticed, there was a little spike in the event hub. You saw that was basically our incoming events. So we now have an input, and before we go and create a query, we're going to go and create an output. So we need somewhere to put this data because the user interface isn't the end the end recipient of this data. We're going to go and add our first output. I'm going to call it archive. We have a number of options to send the data to. We're going to create a SQL database. This option does work, so you can actually select databases that are in the current subscription. You can select the database. You can enter in the username and the password. And this is where my So what we're doing here is we're specifying a database server, just a username, and a table where we're going to archive data. I'm hoping I got my password wrong. Well, I hope I got my password right. Obviously, it's going to go away. It's going to test the output, and it's going to let you know. Now, just so you know what this is, I've pre-created the database. It is a simple table with those 4 values that we saw in the JSON file. I can just drop and recreate this table if I want, and I can also go and see that the content of the table is empty right now. So we're going to go and back to our query job. We're going to specify a query because we now have an input and an output set up. So we can go and find a query. Now, when you go and add a query, it creates a little default query for you. It's select star from, or select star, and then from your input, and then it's going to write it to your output. Now, ours is going to look like this. So we're going to basically take our 4 columns, we're going to read them from the input, and we're going to save them to the output. Let's go and have we can run the test. Okay. So what this is doing is telling you that it doesn't have sample data available. So we just need to go and tell it where it can get the data. We have the option of sampling again from the stream, but that takes a while if you're using this often. Rather, we can go back to that file that we created a moment ago, select the file, go back to my downloads. Now I've imported my file, and now I'm in a position where I can test. Okay, so here's a sample of what the output looks like. It's exactly what we saw in the JSON file in a tabular format that sort of we're more familiar with. You can then go and save, and then after clicking the save button, you have to, for some reason, go and save it again. We're going to go and do that. And then we're going to go and test our little job. So we're going to start the job up. What this does is it actually basically tells the Azure Streaming Analytics to go and collect our input, connect to our output, and actually begin the job. This does take a second or two. I lied, probably about a minute or two. So if we'd like, in the meantime, we can go and have a look at our event hub. So remember, we've basically been submitting our events. You can see there's a number of events. We've got incoming messages, and you can see that there's now outgoing messages. So we know that this was from our query sample, but when our system goes live, you'll see a lot more of those events being dealt with or handled. Try and clean up some of these jobs. All right. No, still waiting. Okay, so we can obviously wait. There we go. We are done. So we can now sort of go back to our database. If we go and query it, we should have all our events coming through. Oh, there we go. Okay, so now we can see how we're actually taking all our events from our event hub, and we're actually placing them into the directly into the database. But this is an option for you if you're actually just looking at importing data. You can sort of use this sort of persistence, and then you could query from this persisted table if you want. But we're actually not going to do that. We want to go and create a real-time query, and we want Power BI to consume that. So we're going to go back into our portal. We have to unfortunately stop the job, which sometimes takes just as long as starting the job up as well. Stop it. Yes. Okay. So we're not going to use Power BI as our target for our data. I've got my Power BI subscription up over here. I'm going to quickly browse my workspace, and as you can see, there's nothing particularly exciting in it. I'll refresh it for you, but nothing. It's a completely empty workspace. And we're still waiting. Okay, stream jobs. So we're going to go and add a second output. So we can come here to our outputs option. We're going to add a second output. We're going to call this one a live stream, and we're going to use the Power BI endpoint. We're then required to authorize. Now, my identity is on a different account, so all right, so we have we've created our event. We're gonna go and provide a dataset name, and we're gonna provide a table name. I'm just gonna be lazy and actually use the term live stream for all of them, but you could obviously create sort of better named names for your target. We're gonna go and create. So we're gonna go away and test that. Just gonna quickly test the output. Okay. We're going to come, so we now have two outputs, and we have one input, and we have one query. Now one of the interesting sort of ways that Stream Analytics has been implemented is that you actually add all your outputs clauses into a single query file. So we actually just append the next query to our system. And just basically, we've got this. We've just explained the query to you. We have this. Our input. We've timestamped by the event process date. So remember, we have 2 times in our file, so we're telling it which one that we want to use. We're then going to tell it to group by a tumbling window of 1 second. So basically, I'm going to take a sample every second. I'm going to then determine the average temperature over that second. Now, we know that we're receiving 5 events every second, so we're getting the average of that window. Then we're going to return the end time as well as the average temperature to our stream. So we're going to go and test that. It's going to ask us again to provide that sample data. All the more reason to be using Visual Studio for your development experience, because this can be a little bit tedious sometimes. Okay, so we now have a sample data set. We can go and test our query. Okay, so we now have the two data sets. We have our archive, which was the first result set, and we have our live stream. Now, when we took our sample of data, it was over an incredibly short duration, so we actually only see one partition coming through. But as we move into our live environment, you're going to see that we're actually going to get a real set. So I'm going to quickly save that up, because we are about another 5-7 minutes. So let's finish this up quickly. Okay, so if we're going to go quickly start our job. Start it up. We're going to tell it to start it up immediately. And our job's going to kick off. Now, if we quickly hop across to Power BI here, you'll actually see that the data set that we created wasn't created when we provisioned the endpoint. It actually only happens when the output is, or when the streaming analytics job is actually set up. So once our streaming analytics job is completed, again another little delay. Just house cleaning while we have a second. All right, so our streaming analytics job has now been created. We're obviously submitting more events to our archive, so new events are coming there, but we should also see something new in our live stream. So you'll see we have a brand new data set there called live stream. So let's go and see what's in there. You'll see that our data set we have live stream also has a table in it called live stream, and it has an average temperature and an end time. So let's go and visualize that. It's probably best done on a line chart. We're going to go and grab the end time, drag that into the axis, bring the average into the values. We're going to end up with a real-time chart. Now, the way Power BI works is that you don't see streaming data in real time in your reports. So in order to sort of visualize this, we're going to go and pin this to a dashboard. Report. So quickly going to save the report. Going to create a NAT dashboard. Dashboard. It's going to go and create our dashboard. Okay, let's go view our dashboard. And here we have our dashboard connected to our real-time analytics, and I hope you can see that. You can see the average temperature sort of rendering in real time. So this sort of concludes our demo and our presentation. So I don't know, Dan, if you want to have a look if there's any questions.
All right, yes. Thank you, Michael. That was great. And the demos all worked. That's awesome.
Yes.
You always cross your fingers for that, especially when you're dealing with the cloud demos too.
That's it. Yeah.
Yeah, the live streaming analytics there and the Power BI, that was very cool.
Yeah, a lot of people haven't actually seen those live data sets yet. So I did this talk a couple of days ago as well, and that was the first time I think anybody in the audience had actually seen a live streaming data set, which is pretty cool if you're looking to wow your boss. Live reports is one of those things that'll do it.
Yeah, definitely. That's neat. Okay, yeah, we do have a few questions here. One goes back to some of the code you were using, in particular the code you were using for the event generator. Is that possible, something that you could maybe share, or have you ever, I don't know, have you ever put together like a tutorial or something that could kind of guide someone how to set this up?
That's always a good idea. So yes, I'm happy to do that. Do we, on the portal that you provided, where I sent you the PowerPoint slides, would you be able to take I'm happy to zip this up and we can add it.
Definitely. We could add that to the event attachments. Yep.
Yes.
Okay.
Yeah. Happy. Yeah. Do that.
Great. Other question I had is, could you recommend like any websites or tutorials or maybe a book or anything that you would recommend to help people get started with this streaming analytics?
So I have not actually found a lot of content, but the best place is always going to be the new Microsoft documents. Let's bring up the Microsoft Docs for you in a second. So obviously, if you just search for Azure Streaming Analytics, going to the Microsoft site, you have this documentation tab over here. They've obviously got a lot of, in the references, they discuss how you can develop against the different libraries. They've got a bit of a getting started, but a lot of it is under this development tab, where you can see, this common query patterns describes that query language. So they give you a whole bunch of sample queries. They show you how you can interact with the different elements, Power BI, Document DB. So this is mostly what I used. I really didn't find a lot out there. So yeah, maybe a good opportunity to actually write a blog post or two about it.
Okay, great. Yeah, and it looked like on that first page you went to there, it did have some samples there that maybe people could take a look at too. Nice.
Yes, there's a lot of, so they've got a couple of ones. You'll see temperature seems to be a very popular theme. One of the samples actually uses a real IoT device. So you actually buy a sample IoT device with a genuine sensor, and then you can go and set that up to provide sort of real-time temperature data. Again, one of the other samples uses the idea of cars going through sort of toll gates, and I think there's also a credit card sample that they use.
Okay. And then we had another question about the output data. So like, where is that stored? I think the one example you showed, you were storing it in an Azure SQL database.
Yes. Okay.
And then what about like with the Livestream one? Does that go anywhere?
Yeah, well, that's exactly. Well, that's the whole point of streaming data. You've got to break it from that mindset that it's being stored somewhere. This is data in transit. And unless you actively choose to persist it, which we did in our archive step, it doesn't actually exist for long. Now, the way event hubs work is that it will, so that's why you need to plug your, okay, so let me just kill that. So that's the other option, is your battery dying in the middle of your presentation. So you can obviously persist it to a database, or the live stream. Basically, the event hubs will hold on to the events for either a day.
Okay, and I think we just lost Michael, but the time is up. Perfect timing. He did an outstanding job, and I think we kind of got the idea is that the data, the one we did persistent, where it was storing it in Azure SQL database table, and then in the other example, he was streaming it a live data set right to Power BI to his tenant, and then he was able to create a report and pin the dashboard, the graphic, the visualization to the dashboard page, and as soon as he did that, then you could see that it was streaming in live on the dashboard page, which was very neat. I want to thank Michael for presenting to our user group. It was great to have him, and make sure that when you close out, fill out the survey. Yeah, I'm not sharing any content right now, I'm sorry. Yeah, make sure you fill out the survey and provide us your feedback, and then we'll be doing the drawing probably tomorrow for the Amazon gift cards for completing that survey. But let us know if you're interested in speaking. We would definitely love to have you speak to our community. Especially first-time speakers, this is a great chance for you to speak to your community. You don't have to do it in front of a big live room at all. You're just doing it on your computer and doing it virtually. And we'll make sure that this recording will be posted to our YouTube channel later on today, probably within an hour or two. Thanks again for everyone for attending, and it was great to have Michael present. I hope you all enjoyed the presentation, and have a great day, evening, morning, whatever it might be in your location. Great. Thanks, everyone. Bye.